Okay, so a function is concave up when its second derivative is greater than 0. So all we have to do is find our second derivative. So first derivative first, and then take the derivative of that to get the second derivative. And we're going to make a sign line to figure out where it's greater than 0. So first we have to know where it's equal to 0. So if I just factor this, I can figure out that it's equal to 0 when either 30x equals 0 or 1 minus 2x squared equals 0. So 30x equals 0 when x is 0. That'll go on my sign line. And then x squared equals a half. So x is going to be plus or minus the square root of a half. So plus or minus root 2 over 2 if you rationalize that by multiplying top and bottom by root 2. So that's where it equals 0. Those are the numbers that are going to go on my sign line, 0, positive root 2 over 2, and negative root 2 over 2. And that is where the second derivative is 0. And then I just need to figure out if it's positive or negative. So I want to plug it into my second derivative. The factored form is the best. I want to plug in something bigger than root 2 over 2. And even though I don't know exactly what root 2 over 2 equals, I'm pretty sure that a billion is bigger than it. So I'm going to plug in a billion into my second derivative. So 30 times a billion, that's something positive. And then 1 minus 2 times a billion is certainly negative. So a positive times a negative is a negative. So I'm negative over there. And if you're comfortable with sign lines, since each one of these roots was just a single root, no double roots or even power roots going on, I am safe to alternate those down. But if you're I remember I spent so much time in calculus even, and I would plug in like, oh, I need to find a number between 0 and root 2 over 2 and plug that in. Wasted so much time doing that. But remember in Algebra 2, they kind of teach you that odd powers cross and even powers touch and turn, but then they forget that when they do their sign lines. So, but yeah, if any of these were double roots or even power roots, then they wouldn't change signs over them. And perhaps I'll do a whole separate video on that later. But right now, however you get it, these are the signs of f double prime. And I want to know where it's concave up. So I'm looking for the positives where the second derivative is positive. And so that's here and here. So for any x's that are between negative infinity and negative root 2 over 2 and 0, unite that with 0 to root 2 over 2, and that is our answer. Ta-da!